Welcome back to the Null Pointer. Remember in our last video when I promised to delve into design patterns? Well, we're making good on that promise today. We're uncovering the 5 design patterns that you'll need in almost 90% of your work, and one you'd be better off without. Stay tuned. But before we get into that, a brief explanation of what are design patterns. Design patterns are well-tested, reusable solutions to common problems we face during software design. Think of them as templates you can mold and adjust to suit your specific situation. They're not ready-made classes or libraries, but more like guidelines that can help you design more flexible, elegant, and ultimately more efficient solutions. Each design pattern typically addresses a unique problem that occurs in specific situations and environments. They fall into 3 categories: creational, structural, and behavioral. Creational patterns handle object creation mechanisms. Structural patterns deal with the composition of classes or objects, while behavioral patterns focus on communication between objects. Learning and understanding these patterns enhances your problem-solving toolkit as a programmer, allowing you to design more sophisticated and effective solutions with less effort. Today we'll be exploring 5 that can make a big difference in your coding routine, and the one you might want to avoid. Stick around till the end to find out which one. Let's kick things off with the factory pattern. This is a creation pattern, which provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. Think of it as a commercial factory churning out different products based on demand. Let's consider an example where you are creating a program to handle different types of documents. Instead of coding each time to create a specific type of document, you can use the factory pattern to create the type of document you need when you need it. As you can see, you don't have to change your code every time you want to create a new type of document. Just use the factory. Next up is the builder pattern. This pattern separates the construction of a complex object from its representation so that the same construction process can create different representations. Consider you're creating a person class. Using the builder pattern, you can set person's properties and create a new instance of that class with properties already set. This design pattern is beneficial when your object has many attributes, especially when some of them are optional. It also provides a clear and concise way to create an object and makes your code more maintainable and readable. The third pattern on our list is the facade pattern. It provides a simplified interface to a complex subsystem. Picture it as the front-facing part of your operations that hides all the intricacies behind the scenes. In this Java code, the system facade class simplifies the interface for the data repository and system service class. By calling perform task, you can execute multiple operations with a single method call. If you've ever developed a program with a complex backend but a user-friendly interface, you've used the facade pattern. Most APIs are built this way. Our 4th design pattern is the decorator pattern. This pattern allows behavior to be added to an individual object, either statically or dynamically, without affecting the behavior of other objects from the same class. Imagine you're coding a coffee dispenser in your program. You'd start with a basic beverage, then use the decorator pattern to add extras like sugar and milk. Each decoration doesn't affect the others, but adds to the overall result. Our final recommended pattern is the strategy pattern. This pattern allows a method's behavior to be selected at runtime. It encapsulates each algorithm in the program, making them interchangeable within that program. Imagine a sorting program where you can select different algorithms to perform the sorting. There are numerous sorting algorithms: quick sort, bubble sort, merge sort, and so on. Now, instead of hard coding the sorting method, wouldn't it be nice if we could select the most appropriate algorithm at runtime? That's exactly what the strategy pattern allows us to do. It helps us encapsulate a series of algorithms, or strategies, and select the most appropriate one based on the situation. Now that we've covered the top 5 design patterns, let's talk about one that you might have already encountered, as it is very prominent in many tutorials. But you might want to be careful with it: the Singleton pattern. Singleton ensures a class has only one instance and provides a global point of access to it. It can be useful in certain scenarios, but can also lead to problems like hiding dependencies and making code hard to test. So what's the alternative? Meet dependency injection. It's a technique where an object receives its dependencies rather than creating them. Here's a basic example of dependency injection. This improves the flexibility and testability of your code. Remember, these are tools in your coding toolkit. Use them wisely. They can make your coding life much easier. And that wraps up our discussion on the topic. Did you find it helpful? What are the design patterns you use regularly? Would you like me to cover more patterns? Let me know in the comments below. Please give it a thumbs up and subscribe to the Null Pointer for more such content. Happy coding. Null Pointer out.